Hey, welcome to Custom Science Academy classes, and we are going to solve uh, this question paper of Mathematics 10 for class 10, and this is set 1 of subset 1 of set 2. So let's quickly move on to the MCQ part, which has 18 questions of 1 marks each and 19 and 20 are assertion and reasoning type. So for first question, it's asked which of the following quadratic equations has sum of its roots as 4. And we know that the sum of the roots, that is alpha plus beta, is equal to negative b by a. And for first equation, a is 2, b is negative 4, and c is 8. And for the first equation, the sum of the roots is negative of negative 4 by a, which is 2, which gives us 2. So this is not the one. And for the second equation, a is equal to negative 1, b is equal to 4, and c is equal to 4. And for this, if we find the sum of the roots, which will give us negative b by a, and b is 4a is negative 1, so this is equal to 4. So this is the second equation, and the equation which has sum of its roots as 4 is b minus x squared plus 4x plus 4 is equal to 0. And let's move on to the second one. Okay, for question number 2, it's asked what is the length of the arc of the sector of a circle with radius 40 centimeter, central angle is 90 degree. So let's say this is the circle and this is the central angle. It's given that central angle is 90 degree, radius is 14 centimeter, and the length of the arc is given by the formula theta by 360 into 2 pi r. So theta here is 90 by 360, 2 into pi is 22 by 7, and radius is 14, which gives us 7 to the 14. This is 9, 4 the 36, 2 2 is 4, 2 and 2 gets cancelled. This is 22 centimeter. So answer for this is 22 centimeter. And let's move on to the question. Okay, for question number 3, it's given that triangle ABC is similar to triangle PQR. So this is triangle ABC and this is triangle PQR. So it's given that triangle ABC is similar to triangle PQR, and angle A is 32 degree and angle R is 65 degree. So we have to find the measure of angle B. So that is, we have to find angle C. Now C, the corresponding angles of the similar triangles are equal. So if you look at the symbolic form, C is equal to angle R. So angle C is equal to angle R is equal to 65 degree. So angle C is 65 degree, and now we have to find angle B. So angle B is equal to 180 minus 32 plus 65, which is equal to 180 minus 32 plus 65 is 7 and 97. This is 10 minus 7 is 3, 17 minus 9 is 8. So angle B is equal to 83 degree, and C is the correct option. Let's move on to question number 4. For question number 4, it's given that P and Q are natural numbers and P is a multiple of Q. So it's given that P is a multiple of Q. So we have to find what is the HCF of PQ. Now let's consider that this way. Let's say 4, 12. Now let's say if 12 is a multiple of 4, then HCF of 12 and 4 highest common factor is 4. So that means the smaller one is the HCF, and in this case P is a multiple of Q, so that means HCF of P and Q is Q. So answer for this is C, which is Q. Let's move on to the fifth one. Okay, for question number 5, it's given that coordinates of the vertex A of a rectangle ABCD whose three vertices are. So what are the coordinates of vertex A? So we can also find it using the distance formula, but it would be easier if we just quickly draw it on the in the plane. Okay, the first coordinate is 0, 0. So the B is at 0 and the C is 3, 0. So let's say this is 3, 0 and this is B, and D is 0, 4. So let's say 0, 4 is on y-axis. So let's say this is D, and we have to find the coordinates of the vertex A. So vertex A is here, and if we join them now, because this is a rectangle, so that means this distance is equal to this, and this distance is 3 because this coordinate is 3 comma 0. So this is 3 units, and opposite sides are equal. So this distance is 4 units, which makes this 4 units. So the coordinates of A are 3 comma 4. So for this, the answer is 3 comma 4. For the fifth one, let's move on to the sixth one. For question number 6, uh, it's given that the pair of equations, and we have to find the value of r for this, for which these pair of equations represent coincident lines. So our pair of equations are 3x minus y plus 8 is equal to 0, 6x minus ry plus 16 is equal to 0. And now here a1 is 3, b1 is equal to negative 1, c1 is equal to 8. Similarly, a2 is equal to 6, b2 is equal to negative r, and c2 is equal to 16. Now, for coincident lines, a1 upon a2 is equal to b1 upon b2 is equal to c1 upon c2. Let's put in the respective values. So 3 upon 6 is negative 1, negative r, 8 by 16, which gives us 1 by 2. This is 1 by 2. So 1 by 2 is equal to 1 by r, which gives us the value of r is equal to 2. So the value is 2. And let's move on to question number 7. For question number 7, uh, there's a bag that contains 100 cards numbered 1 to 100, and card is drawn at random from the bag. So what is the probability that number on the card is a perfect cube? So for question number 7, we know that the perfect cubes from 1 to 100, they are, it's 1 cube is 8, 3 cube is 27, 4 cube is 64, and 5 cube is 125, which is greater than 100. So these are 4. So the probability of getting the perfect cube when one card is drawn randomly from the number getting 1 to 100. So this is 4 by 100, which gives us the answer probability 1 by 25. So the option is option C. And let's move on to question number 8. Before question number 8, now we have to find the pair of equations x is equal to a, y is equal to a. Graphically represent lines which are either parallel, intersecting at BA, or coincident. So let's try to sketch their graph. Now x is equal to a is a line parallel to y-axis. So these are x and y-axis. This is x and this is y. Let's say this is distance a. Now x is equal to a is a line which is parallel to y-axis. So this is x is equal to a, and y is equal to b is a line which is parallel to x-axis. So let's say this is y is equal to b, and this distance is b, and this distance is a. So this point of intersection is a comma b. So these are, this is the line y is equal to b, and this is the line x is equal to a. and both of these are intersecting at AB, so our option for this should be intersecting at A. So D is the correct option. Let's move on to question number 9. For question number 9, it's given that one zero of the polynomial is reciprocal of the other. So let's say two zeros are alpha and beta, and one is the reciprocal of other. Now, the given quantity equation is 6x squared plus 37x minus k minus 2. And we know that, so whenever it's given that the one is the reciprocal of the other, so we will consider the property, the product of the two zeros, and which is equal to c by a. So alpha is 1 by beta into beta, and c is minus k minus 2 by a is 6. So this gets cancelled, it is 1. So 1 is equal to minus k by 2 is equal to 6. And minus k plus 2 is equal to 6, which gives negative k is equal to 4. And the k is equal to negative 4. So negative 4 is the answer. So A is the correct option for question number 9. And let's move on to question number 10. Okay, for question number 10, we have to find the total surface area of a solid hemisphere of diameter d. And this is question number 10. So the solid hemisphere will be something like this. And it has a diameter. This is the diameter, which is d. So its radius will be equal to d by 2. Now the total surface area of the hemisphere, it's a solid hemisphere. So its total surface area is area of the circular part, which is pi r square, and area of this curved region, which is 2 pi r square, which is equal to 3 pi r square. And let's substitute the value of r, which is d by 2 the whole square. Now this is 3 pi into d square by 4, which gives us 3 by 4 pi into d square. So this is the correct option, option D. Let's move on to question number 11. For question number 11, it's given that if three coins are tossed simultaneously, what is the probability of getting at the most one tail? So this is question number 11. Now there are three coins that are tossed simultaneously. So here the total outcomes is for one coin, we have total outcomes 2, and because it's three coins, so we'll put them in the power. So this is 8. And let's write down the 8 outcomes. And how we'll write, we will get the half of 8, which is 4. We'll write down 4 times head and 4 times tail. Now half of 4 is 2, which is 2 times head and 2 times tail. So head and tail, and half of 2 is 1, so which is one head, one tail, one head, one tail, one head, one tail, one head, one tail. So this is the sample space. Now let's understand at most one tail. So the probability of getting at most one tail means the probability of one tail or zero tail. So that is the meaning of at most. At most means 1 and less than 1. So it's 1 and less than 1 is 1 and 0. So we have one tail here, one tail in this, and one tail. So there is no tail here. So this is 1, 2, 3, and one tail here. So we have total of 1, 2, 3, and 4. So this is 4 favorable outcomes out of 8, and 4 by 8 is the option B. So here the correct option is option B. And let's move on to question number 12. Okay, for question number 12, it's given that DE is parallel to BC, and so this is what's given in the question. This is the triangle ABC, ABC, and DE is parallel to BC, so it's 2, 3, 3, and X. So it's given that DE is parallel to BC, therefore we can use VPT theorem, basic proportionality theorem. So by using that theorem, we get, so this is AD by DB is equal to AE by EX, and AD is 2, DB is 3, AE is 3, and EX is X. So let's cross multiply this, which gives us, so this gives us that it's 2x is equal to 9 and x is equal to 9 by 2. So 9 by 2 is the correct option, which is option 2, D. And let's move on to question number 13. Okay, for question number 14, we have to find the zeros of the polynomial, and the quadratic polynomial is x squared plus 4x plus 3, which can be written as x squared plus 3x plus x plus 3. And if we take x common, this is x plus 3, 1 into x plus 3. So this is x plus 3, x plus 1. So that means x is either equal to minus 3 or x is equal to negative 1. So our option is option D. So D is the correct answer for question number 14. Let's move on to question number 15. For question number 13, it's given that we are on question number 13. So for question number 13, it's given that the hour end of a clock is 6 centimeter long, and we have to find the angle swept by it between 7:20 a.m. to 7:55 a.m. Now, the time, this is the 7:20 a.m. So 7:20 a.m. to 7:55 a.m. So 7:55 to 7:20 a.m., which is equal to 35 minutes. Okay, now we have to find the angle swept by this hour and in, so angle swept by hour and in 35 minutes, that is from 7:20 a.m. to 7:55 a.m. That's what we are supposed to find out. Okay, for that we know that an hour and it sweeps an angle of 360 degree in 12 hours. So if it's at 12 at midnight, then till 12 in the noon, it sweeps an angle of 360 degree. So angle swept by hour and in it's 12 hours. So in 12 hours, this angle is 360 degree. So similarly, the angle swept by hour and in 1 hour, that would be 360 by 12, which is equal to 30 degree. So that means in 1 hour it sweeps an angle of 30 degree, and 1 hour means 60 minutes it sweeps an angle of 30 degree, and in 1 minute it sweeps an angle of 30 by 60, which is half degree. And we have to find it for 35 minutes. So 35 minutes it sweeps an angle of half into 35 degree, which is 35 by 2 degree. So in 35 minutes, that is from 7:20 to 7:55, it sweeps an angle of 35 by 2 degree, and this is option B. So option B is the correct answer. That is the question number 13. And let's move on to question number 14. Okay, for question number 15, there is a quadrilateral PQRS that circumscribes this circle, and we have to find PA plus CS. So PA plus CS is equal to what? Question number 15 now. PA is equal to this, PA is equal to PD, And similarly CS. So CS is equal to SD because these are the tangents drawn from an external point to a circle are equal. So tangents drawn from a external point to a circle are equal. Now let's replace the values here. So P plus CS is equal to, this is CS. Now PA is equal to PD and CS is equal to SD. So PD plus SD. So PD plus SD gives us PS. Okay, so this is option C. So option C is the correct answer. And let's move on to question number 16. For question number 16, it's given that alpha and beta are the zeros of the quadratic polynomial, and our quadratic polynomial is p of x is equal to x squared minus ax minus b. So the coefficient of x squared is a, let's say it's a1. So a1 is 1 and b1 is negative a and c1 is, let's say, negative c. Now we have to find the value of alpha square plus beta square. So alpha plus beta here is negative b1 by a1, which is negative of negative a by 1. So this is a. And alpha beta is c1 by a1, which is negative b. Now we have to find the value of alpha square plus beta square, and this we can get from the formula a plus b the whole square, which is equal to a square plus b square plus 2 alpha. Now let's replace the respective values. So alpha plus beta is a square and alpha square plus beta square be as it is, and 2 into alpha beta is negative b. So this is negative b. So this gives us alpha square plus beta square is equal to a square plus 2b. So the correct option for this is a square plus 2b, which is option B. So B is the correct answer for question number 16. Let's move on to question number 17. Okay, for question number 17, we have to find the area of the triangle formed by the line x upon a plus y upon b is equal to 1 with the coordinate axis. Now this line is intersecting the coordinate axis, both the coordinate axes. Let's say this is the line which is intersecting the coordinate axis, and these are the coordinate axes x and y. So this is x and this is y, and this is the line that has the equation x plus a upon y plus b is equal to 1. Now this line intersects the y-axis at this point, and coordinates of this point are 0, comma y. And if we put this 0, comma y in this equation, which gives me x is 0, so 0 upon a plus y upon b is equal to 1. So this is 0, which gives me y is equal to b. So that means it's 0, comma b. So y is b. So that means this distance is b. And now this coordinate is x comma 0, and if we put this x comma 0 in this equation, which gives me x upon a plus y upon 0 is equal to 1, which gives me x is equal to a. So that means the coordinates of this point are a comma 0, and the coordinates of this point are a comma 0, and this distance is a. Now this is the triangle that is formed, and the area of the triangle is half into base into height. So this is half into AB square. E units is the area of the triangle, which is half AB, which is option B. So option B is the correct answer for question number 17. Okay, for question number 18, it's given that AB is parallel to PQ, and let's say this is angle 1 and this is angle 2. So AB is parallel to PQ and BP is last question. So AB is parallel to PQ and BP is a transversal. That means angle 1 is equal to angle 2. And because these are alternate interior angles are equal. And also angle O is equal to angle O. These are vertically opposite angles. So therefore, by a similarity rule, this triangle ABO is similar to triangle. So ABO, let's write it in the symbolic form. So O is equal to O and B. This angle B is equal to P, so it's P and QPO. So once these triangles are similar, that means that the sides are in proportion. We can write AB. So AB upon QP is equal to, next is BO. So BO upon PO. Or we can write it as OP. Let's put in the respective values. AB is 6, QP is 2, and BO is 3. We have to find OP. So cross multiplying this gives us 6 into OP is equal to 6. So OP is equal to 1 centimeter. So for this, it's option D. So D is the correct answer. Let's move on to question number 19 and 20. For question number 19, it's given that assertion a tangent to a circle is perpendicular to the radius to the points of contact, which is true. So this is true because we know that whenever we draw, so let's say this is the radius, and if we draw a tangent through the point of contact, then this radius is perpendicular to this tangent. So this is true. And the length of tangents drawn from an external point to a circle are equal. This is also true. So length of the tangents drawn from an external point to a circle, these two lengths are equal. So length of the tangents drawn from an external point should be equal. This is also true, but this is not the correct explanation of A. So both position A and reason are true, and reason R is not the correct explanation of A. So correct answer here is option B. Let's move on to question number 20. Question number 20. Uh, it's given that for assertion the polynomial p of x is equal to x squared plus 3x plus 3 has two real zeros. We have to check that. And for that, we have to find the discriminant. So polynomial is 2x is x squared plus 2x plus 3, where a is equal to 1, b is equal to 2, and c is equal to 3. Let's find out b, which is equal to b square minus 4ac. So this is 2 square minus 4 into a, 1 into c is 3, which is 4 square minus 12, which is negative, which is less than 0. So roots are not real. So that means assertion is false. Now a quadratic polynomial can have at most two real zeros, which is true. So in this case, assertion is true, but reason R is false. So option C is the correct answer. Let's move on to question number 21. Okay, for question number 21, section B, and this section comprises of 2 marks questions, and we have to prove that 2 plus root 3 is an irrational number. So let's say 2 plus root 3 is a rational number. So if 2 plus root 3 is a rational number, that means it can be written in the form a upon b, where a and b are integers. Now this gives us, if we cross multiply this, so root 3 is equal to this can be written as So 2 plus root 3 into b is equal to a, which gives us 2b plus root 3 into b is equal to a, and root 3 is equal to a minus 2b by b. Now this is rational. A minus 2b is rational because a and b are integers, so this is a rational number, and rational should be equal to rational because this statement is an equality statement. So which gives us root 3 is a rational number, but root 3 is an irrational number. So this contradicts our assumption, which contradicts. So this contradicts our assumption that 2 plus root 3 is irrational number. Hence, 2 plus root 3 is an irrational number. Okay, so this proves our question number 21. Let's move on to question number 22 for both the parts. Okay, for question number 22, okay, for question number 22, we are going to solve the part 1, which says that we have to find the value of p if this is given, that is 4 cot square 45 degree minus secant square 60 degree plus sine square 60 degree plus p is equal to 3 by 4. Now, cot 45 is 1, so this is 4 into 1 square, and the secant 60 is the opposite of cos 60, which is half. So this is 2 square plus sine 60 is root, it's 2 by, so sine 60 is 2 by root 3, sorry, root 3 by 2. So this is root 3 by 2 the whole square plus p is equal to 3 by 4. So this is 4 minus 4 plus 3 by 4 plus p is equal to 3 by 4. So this gets cancelled. 3 by 3 by 4 gets cancelled. So the value of p is equal to 0. Now let's move on to part B. So part B is we have to find the value of, so it's given that cos A plus cos square A is 1. So this is the value that's given. Now we have to find the value of sine square A plus sine raised power 4A. Okay. From this, we can get a cos A is equal to 1 minus cos square A, and 1 minus cos square is sine square A. Now, instead of sine square A, instead of sine square A, we can write cos A. So this becomes cos A plus. Now sine raised power 4A is cos square A. So now cos square A plus cos square A is 1. So from here we evaluated, we find out that cos A is equal to 1 minus cos K, which is equal to sine square A. So cos A is equal to sine square A. We got that cos A is equal to sine square A, and cos square A will be equal to sine raised power 4A. So just replace the values. So sine square A is cos A, and sine square A is cos A, and sine raised power 4A is cos square A. So this becomes cos A plus cos square A, and this value is given to us, which is 1. So this solves our question number 22. Let's move on to question number 23. For question number 23, we have to show that the given points are the vertices of a right angle triangle. So let these vertices be A minus 2, 3, B 8, 3, and C, 6, 7. Now we have to show that these are the vertices of a right angle triangle. For that, let's find out AB. And this is x2 minus x1 the whole square. So 8 minus of minus 2 is 10, plus 3 minus 3 is 0. So this is equal to under root of 10 square, which is 10. Now let's find out BC. So BC, using the distance formula, it's 6 minus 8 is minus 2 the whole square. 7 minus 3 is 4 the whole square, which gives us 4 plus 16, which is root 20. Now let's find out AC. We'll find out all the three sides. So AC, so this is AC, which is 6 minus of minus 2 is 8 square. 7 minus 3 is 4 square, which gives us 64 plus 16, and which is 6, 4, 10, and this is 80. Now 80 can be written as, so 80 if factorized. So this gives me 2 into 40, 2 into 20, 2 into 10. And this is equal to under root 2 into 2 into 2 into 10. So this is 2 under root 20. Now, and let's get the square of all the sides. So AB square is equal to root of AB square is equal to 10 square is 100, and BC square is equal to root 20 square, which is 20. And let's find out AC. So AC square is equal to 2 under root 20 the whole square, which is equal to, this is 80. Now let's add the smaller sides. So this one is the longest side, largest 100. So if we add AC square plus BC square, that is 80 plus 20, which is equal to 100, and that is equal to AB square. So that means the sum of the square of two sides is equal to the square of the third side, and this is possible only in a right angle triangle. Therefore, ABC, these are the vertices of a right angled triangle. So we have shown that these are the vertices of a right angled triangle. Let's move on to question number 24. Before question number 24, part A, and this is question number 24, we are doing the first part. It's given that the length of the shadow of a tower on the plain ground is 3 times the height of the tower. So let's say this is the height of the tower and this is the length of the shadow of the tower. So AB is the height of the tower, BC is the length, and let's join this to the line of the side. We have to find the angle of elevation of the sun, so we have to find angle C. Okay, now it's given that the length of the shadow. So let's just write it. Let AB be height of the dark and BC be the length of shadow. Now it's given that the length of the shadow, that is BC, is root 3 times the height of the shadow, which is AB. Now this can be written as, in the ratio, this can be written as, let's shift this to right hand side and this to the left hand side. So this is 1 by root 3 is equal to AB by BC. Now AB by BC is tan of C. So this I can write it as tan of C. So tan C is equal to 1 by root 3, and we know that the angle for which the value is, for which the value of tan is 1 by root 3 is tan 30. So that means C is equal to 30 degree. That means the angle of elevation of the sun is 30 degrees. So angle of elevation of sun is equal to 30 degree. Now let's move on to part B of the same question. So For part B, it's given that the angle of elevation of the top of a tower from a point on the ground is 30 degree, and we have to find the height of the tower. So part B, question number 24. Part B, let's say this is the height of the tower, and there's a point on the ground which is 30-meter away from the foot of the tower, and the angle of the elevation is 30 degree. So angle of the elevation is 30 degree, and let's label this. So this angle of elevation is 30 degree. We have to find the height of the tower. Let's say AB with the height of the tower, and the distance of the point from the foot of the tower is 30-meter. Now let AB be the height of the tower. We have this right angle triangle. So in right angle triangle ABC, it's tan 30 degree, which is equal to AB by BC. Now we know the value of tan theta is 1 by root 3 AB, and BC is 30. So if you cross multiply this, which gives me AB is equal to 30 by root 3, and let's rationalize this, which gives us 30 root 3 by 3, and this is 10. So 10 root 3 meter is the height of the tower, and we can write that height of the tower is equal to 10 root 3 meters. And this solves our question number 24. Let's move on to question number 25. Question number 25, it's given that O is the center of the circle, and AB and AC are tangents drawn to a circle from point A. So in this figure, angle B is equal to angle C. The angle B is equal to angle C is 90 degree because the radius is perpendicular to tangent at the point of now let's use the angles and property in quadrilateral A B O C. Angle A plus angle B, and this is angle BOC plus angle C is equal to 360 degree, and this is because of the angle sum property of a quadrilateral. Now angle A is 65 degree, angle B is 90, angle BOC we have to find out, angle C is 90. So 90 plus 90 is 180, 180, and 180. We will subtract 180 and then 65 from 360, which will give us angle BOC. So 360 minus 180 is 180, and 180 minus 65, 10 minus 5 is 5, and 7 minus 6 is 1, it's 115 degrees. So angle BOC is equal to 115 degrees. Okay, for section C, and this section comprises of 3 marks questions. Let's move on to question number 26, part A. And we have to find the prime factorization. By the prime factorization, we have to find the LCM of 1810 and 7575. So let's factorize them. It's 1810 and 7575. So dividing it by 2, so 2 nines are 18, 090 again by 2, this is 45, 45, and now this goes with 5, so 5 nines are 45, 9, and this goes with 3, so 303 and 3 and 101. So 18180 is equal to 2 square into 5 into 3 square into 101. And let's divide 75, so it's 5 ones are 5, 525, 1, 5. So it's 5 and 303, which gives us 3101. So 7575 is equal to, this is 5 square into 3 into 1 over 1. Now let's find the LCM. So we have to find the LCM and also find the HCF. So LCM is, so between 5 square and 5, it's 5 square for 3 square, and 3 it's 3 square. It's run 1 into 2 square. So 5 square is 25 into 9 into run 1 into 4. So 25 into 4 is 100 into 9 into 101. So 100 into 9 is 900 into 101, which gives us 90900. This is the LCM. And to find out the HCF, so we have to take the smallest among the common factors. So this is 5 into 3. So, and 101 into 101, which gives us 15 into 101. And this is now equal to 15 into 101 is 1515. Okay, so this is the HCF and the LCM of the two numbers. And let's move on to the part B of the same question. It says that three bells ring at intervals 6, 12, and 18. If all the three bells ring at 6 a.m., when will they ring together again? So for this, we have to find the LCM once again, and LCM of 6 can be written as 2 into 3, and 12 is 4 into 3, which is 2 square into 3, and 18 is 6 into 3, which is 2 into 3 square. Okay, now LCM here is, so among these, it's 2 square, and among these, it's 3 square. So 2, it's 4 into 9 is equal to 36. So these bells when ring together, so 3 bells will ring together after 36 minutes. That is at 6:36 a.m. And this is also question number 26. Let's move on to question number 27. Before question number 27, we have to prove the trigonometric identity. And it says that 1 upon cos theta minus cos theta uh, multiplied with 1 upon sin theta minus sin theta is equal to 1 upon tan plus cos theta. So let's consider the left hand side. So this is 1 upon cos theta minus cos theta into 1 upon sin theta minus sin theta. Okay, which gives us, this is cos theta 1. Let's take LCM. So LCM on for both the terms, it's 1 minus, this is cos square theta, 1 minus sin square theta. Now 1 minus cos square theta is sin square theta. My cos theta, and 1 minus sin square theta is cos square theta by sin theta. So this gets cancelled, this gets cancelled, and finally we have sin theta into cos theta, and this is equation 1. Now let's also consider the right hand side. So considering the right hand side, which is equal to 1 upon tan theta plus cos theta. So tan theta is, we know that tan theta is sine upon cos theta, cot is cos upon sine, and LCM here is cos theta into sine theta, which gives us sine square theta plus cos square theta. Sine square theta plus cos square theta is 1. So this is equal to 1 upon 1 by cos theta into sin theta, which is equal to cos theta into sin theta. This is our second result. And we can say that from 1 and 2, LHS is equal to RHS. Hence, we have proved the identity. Let's move on to question number 28. Okay, for question number 28, it's given that Q is equidistant from the 2 points. So question number 28, and it's given that the point Q, which is 0, 1, it's equidistant from P 5 minus 3 and R, which is x 6. Now this point is equidistant. The Q is equidistant means the distance of Q from P, which is PQ, and distance of Q from R, which is QR. This is equal. Now we know how to find the distance between PQ, which is the distance formula, which is x2 minus x1. So 5 minus 0 the whole square plus minus 3 minus 1 the whole square is equal to, this is x minus 0 the whole square for QR. Using the distance formula is 6 minus 1 the whole square under root. Now the under root gets cancelled if we square both these sides. So this is 5 square, which is 25, minus 4 square is 16. This is x square. 6 minus 5 is, so 6 minus 1 is 5. 5 square is 25. 25, 25 gets cancelled. And x square is equal to 16, which gives us x is equal to plus minus root of 16, which is equal to plus minus 3. And we have to find the values of x. So x is equal to 4 or minus 4. These are the two values of the x. Let's move on to question number 29. For question number 29, it's given that a car has two wipers which do not overlap. So let's say this is the front mirror of the car. Now it has two wipers which do not overlap, and the length of the two wipers, the blade, is 21 centimeters. So it's 21 centimeter. That's the length of the blade of the wiper, 21 centimeter, and they makes an angle of 120 degree when they clean up the area. So we have to find the total area cleaned at each sweep of two blades. So there are two blades, and this is the area cleaned, which is in the form of the sector. So total area cleaned at each swipe of two blades. Now that will be equal to theta by 360 into pi r squares. This is the area cleaned by one blade at each sweep, and we have two blades, so this has to be multiplied by 2. Now let's put in the value. Theta is 120, phi is 22 by 7, r square is 21 into 2, so 7 3s are 21, 3 gets cancelled with 120, this gets cancelled, and now it's 44 into 21, which gives us 924 centimeters square. So 924 centimeters square is the area cleaned at each swipe of the two blades. And let's move on to question number 30. Okay, for question number 30, part A, it's given that the system of linear equations has infinite number of solutions. So our system of equations are 3x plus y is equal to 7. And the second one is 2ax plus a plus b into y is equal to 28. Now, we know that for infinite number of solutions, their coefficients and the constant should be in the ratio. So for infinite number of solutions, a1 by a2 should be equal to b1 by b2 should be equal to c1 by c2. Let's put in the respective values of a1. a1 is 2, the coefficient of x, a2 is 2a, B1 is 3 and B2 is A plus B, and C1 by C2 7 by 28, which should be equal to 1 by 4 now. And let's equate them one by one with the constant term, which is 1 by 4. So 2 by 2a is 1 by a is equal to 1 by 4, which gives us a is equal to 4. And let's equate this term, which is 3 upon a plus b is equal to 1 by 4. So a plus b is equal to 12, and a is 4. So 4 plus b is equal to 12, which gives us b is equal to 12 minus 4, and b is equal to 8. So a is equal to 4 and b is equal to 8. And let's try to solve the second part. And in this, for we have to solve the linear equations which are given as 217x plus 135y is equal to 913, and 131x plus 217y is equal to 827. We have to solve them. Okay, these is a special case where we see that the coefficient of x matches with the coefficient of y, and coefficient of y of one equation matches with the coefficient of x. And this is 120 to 131. So in this case, we will add these equations one, and then we will subtract them. So adding them gives 217 plus 131 is 7 plus 1 is 8, 3 plus 1 is 4, and 348x plus 348y. And now this is equal to 7 plus 3 is 10, 2, 3, and 4, and 9 and 8 is 17. So it's 18740. Now we can take 348 common. So if 348 is common, this is x plus y is equal to 1740. So x plus y is equal to 1740 divided by 348, and let's try to multiply it by 5. So it's 45 over the 20, 24, and 71, 74. So this gets cancelled with 5. And this equation has been reduced. We have got another equation which is x plus 5 is equal x plus y is equal to 5. Let's say this is equation 1. Okay, so we have added it once. Now we are going to subtract it to get another equation. So this is 217x plus 131y is equal to 913, and this is 131x plus 217y is equal to 827. And okay, now let's subtract these equal to 7 minus 1 is 6, 11 minus 3 is 8, 86, and this is negative. So 7 same, it's negative 86y, and this is 13 minus 7 is 6, 10 minus 2 is 8, and this is negative 80, sorry, this is positive 86. So 86 is common, and it's x minus y is equal to 86. So this gives us x minus y is equal to 1. So we have two equations, x plus y is equal to 5 and x minus y is equal to 1. And if we add them, so adding them will gives us 2x is equal to 6, which gives us x is equal to 3. And let's subtract them once again. So x plus y is equal to 5, x minus y is equal to 1. Subtracting them will change the sign. So this gets cancelled. It's 2y is equal to 4 and y is equal to 2. So the value of x is 3 and y is 2. And this is also question number 30. Let's move on to question number 31. Okay, for question number 31, it's given that O is the center of the circle, QPR is a tangent. We have to prove that angle QAP plus angle APR is equal to 90 degrees. Now, in this case, we have to prove that angle, this is QAP. So what's given in the question is QPR is a tangent at P, which is a point of contact, and we have to prove that angle QAP plus angle APR is equal to 90 degrees. Let's first try to use what we have. in the chapter. So its OP is perpendicular to QR. Reason being, radius is perpendicular to tangent at the point of contact. Now, if OP is perpendicular to QR, that means angle OPR is equal to 90 degree. Now OPR, this angle OPR, it's made up of two angles, angle OPA and angle APR is equal to 90. So we have broken OPR into angle OPA and angle APR. Now OPA is equal to angle OAP. So instead of OPA, I can write angle OAP, and let's mention the reason. So angle OAP is equal to angle OPA because OA is equal to OP. So OA is equal to OP, and this gives us this because angles. So we can say that OA is equal to OP. So this gives us this because angles. So OA is equal to OP. The reason for this is radii of same circle, and the angles opposite to two equal sides are equal. So that's why we have right angle OAP. Now OAP. So OAP, I can write it also as QAP. It's one and the same thing. So instead of OAP, I can write QAP because the arm of the angle OA is produced to Q. So that remains the same angle. This is what was asked to prove. So QAP plus angle API is equal to 90 degree. And let's move on to section D, which is of long answer type questions of 5 marks each. Okay, for question number 32 for section D, and we have to find the number of the terms of the AP so that the sum is 120, 180, sorry. So this is given AP is 45, 39, 33, and it goes like this till n terms. Now A here is 45 and D is 39 minus 45, which is negative 6. Okay, now it's given that sum of the n terms is 180. So what would be the value of n? Now sum of n terms is n by 2 into 2a plus n minus 1 into d is equal to 180. We have to find the value of n. We know the value of a, which is 45, and minus 1d is negative 6 is equal to 180. So this is n, and 2 get shifted to that side, which is 362 into 45 is 90, and this is minus 6n plus 6 is equal to 360. Okay, now our equation is n, and this is minus 6n plus 96, which is equal to 360. This is minus 6n square plus 96n is equal to 360, which can be written as 6n square minus 96n plus 360 is equal to 0. So 6 is common, which is 9 square minus 6 1 the 6 6 6 are 36 plus 60 is equal to 0. And now we have to solve this quadratic equation, which is n square minus 16x 16n plus 60 is equal to 0. And we know that the factors of 60 are 10 and 6, so we can put them 9 square. It's 10n minus 6n plus 60 is equal to 0. So this is n minus 10 minus 6 into n minus 10 is equal to 0. So n minus 6 into n minus 10 is equal to 0, which gives us the number of terms is either 6 or the number of terms is either 10. Now we have got the double answer, so we have to explain that why the sum of 6 terms and the sum of n 10 terms is 60. So the sum of 6 terms is also 180, and the sum of 10 terms is also 180. How is that possible? This is possible. Let's say these are the 6 terms: 1, 2, 3, 4, 5, and 6. And after that, the 4 terms are minus 6, 6, 6, and minus 6. So this gets cancelled, and the sum of these terms is still 0. So all till here, the sum was 180, and 180 plus 0 is still 180. So that means that some terms are positive. So some terms are positive and some terms are negative after sixth term, and their sum is 0. So that's why sum of 6 terms is 180 and sum of 10 terms is also 180. Okay, now let's move on to question number 33. Okay, for question number 33, it's given that as observed from the top of a 75-meter high lighthouse. So this is, let's say, the 75-meter high lighthouse. The angles of depression of two ships. So let's say the two ships are in the same line, and this is the position of ship A, and this is the position of ship B. So this is A, B, C, and D. CD is the height of the lighthouse, which is 75-meter high, and the angle of depression of the two ships from the lighthouse. So these are the angle of depressions of the two ships from the lighthouse, and these are found to be 30 and 60 degrees. So the farther one will be the smallest one. This is 30 degree. So this is 30 degree, and this one is 60 degrees. So this is 60 degrees. Now we have to find the distance of the two ships. It's given that we have to take the value of root 3 is equal to 1.73, and the distance between the ships is AB. So AB we have to find. Let's declare what we have assumed. So CD is equal to 75 meter, be the height of lighthouse. Okay. Now I will go with the triangle, which is the smaller one, that is in right angle triangle BDC. I will use 10 and find out the distance BC. So in right angle triangle BCD, which is right angle at C, let me use tan 60, which gives me DC by BC, and tan 60 is root 3, so DC is 75 BC. And if we cross multiply this, so this gives us BC is equal to 75 by root 3, and rationalizing this with root 3 gives 75 root 3 divided by 3, which is 25, and that is equal to 25 root 3. So BC is 25 root 3, and we have to find the distance of AB. Now we have one more right triangle, which is the bigger one, and in right angle triangle ACD, which is right angle at C. I'm once again going to use the ratio tan 30, which is equal to DC by AC. Now tan 30 is 1 by root 3, DC is 75, and AC can be broken into AB plus BC. So 1 by root 3 is equal to 75. AB we have to find out, and BC it's 25 root 3. And let's cross multiply this, which gives us AB plus 25 root 3 is equal to 75 root 3, and AB is equal to 75 root 3 minus 25 root 3, which is 25. Okay, 75 minus 25 is 50 root 3, and it's given in the question that we have to take the value of root 3 as 1.73. 1.73, so let's substitute the value, and 173 into 5 is 5 3s are 15. It's 15, 7 for the 35, 36, 8. So this is 8,650, and this is 86.5 meter is the distance between the ships. So move on to second part. So for the second part, let's get some space on the board. Okay. Okay, now for the second part, it's given that from a point on the ground, the angle of elevation of the bottom and top of a transmission tower fixed at the top of a 30-meter high building. So let's say this is the 30-meter high building, and on top of this, we have fixed a transmission tower. So this is the height of the building, which is 30 meter. And on top of that, we have fixed a tower, transmission tower, and it's given that from a point on the ground. So let's say this is a horizontal ground, and there's a point on the ground. From here, the angle of elevation of the bottom and top. So bottom of the tower is here. So from the bottom, there's the angle of elevation, and from the top, we have the angle of elevation at the ground, and these angle of elevation are 30 and 60 degrees. So this is 30 degree, and this is 60 degree with the top. We have to find the height of the transmission tower, given that root 3 is equal to 1.73. We have to take the value of root 3 is equal to 1.73. And let's label this. This is, let's say, A, B, C, and D. And we have to find the height of the tower. So let AB be the height of the tower, and BC is equal to 30 meter, B height of the building. Now, as usual, let's start with the smaller right angle triangle. So in right angled triangle BCD, which is right angled at C. So right angled triangle BCD, it's tan 30, that is equal to BC by DC. So tan 30 is 1 by root 3. We know the value of BC, which is 30, and it's DC. So cross multiplying this gives DC is equal to 30 root 3 meter. So we have got the value of DC. Now let's use the bigger one, the right angle triangle. So in right angle, the triangle, that is ACD, it's tan 60, that is equal to AC by DC. Now tan 60, value of tan 60 is root 3. AC can be broken into AB plus BC. So this is AB plus BC by DC. Now let's put in their values. So the value of AB, so it's root 3 is equal to AB. We have to find out the value of AB plus BC is 30, and DC is 30 root 3. If we cross multiply this, this is AB plus 30 is equal to 30 root 3 into root 3. So root 3 into root 3 is 3, so this is 90, and AB. So AB is equal to 90 minus 30, which is equal to 60 meters. So height of the transmission tower is 60 meter. So height of the transmission tower is 60 meter. We can write that height of transmission tower is equal to 60 meters. Okay, and this finishes our question number 30. This was question number 33, and let's move on to question number 34. Here we are on question number 34, and for question number 34, a student noted the number of cars passing through a spot on a road for 100 periods, each of 3 minutes. And he summarized this table below. We have to find the mean and median of the following data. So it's not mentioned whether we have to use any specific method. So you can use any of the method to find the mean. And let's summarize this data once again. The first column is it is of the number of cars in the form of interval, and the intervals are 0 to 10, 10 to 20, 20 to 30, 30, 40, 40, 50, 50, 60, 60, 70, and 78. Okay, so this is the number of cars and the frequency. For 3 minutes, he spotted he spotted on a road for 100 periods, each of 3 minutes, and the frequency for each of these class intervals, which is Fi. So these are the class intervals, and the frequency is 7, 14, 13, 12, 20, 11, 15, and 8. Okay, now let's find out the class marks, which are denoted by xi. And we know how to find the class marks. It's upper limit plus lower limit divided by 2. So upper plus lower divided by 2 is 5, and 10 plus 20 is 30 divided by 2 is 15. So 20 plus 30 is 50 divided by 2 is 25, and 25 plus 10 is 35, 45, 55, and 65, and 75. And now let's try to get the product of Fi into Xi. So 7 into 5 is 35, and 14 into 5. 14 into 15 is 210. So 14 into 15 is 210. 13 into 25. 13 into 25 is 325. So this is 325. 12 into 35. 12 into 35 is 420. So this is 420. 20 into 45 is 900. And 11 into 55 is 605. 605, and 15 into 65 is 975. 8 into 75 is 8 5s are 40, 856, and 600. Okay, let's also try to, okay, now the sum total of the frequency, we all know it's 100. And let's find out the sum total of sigma fi into xi. So sigma fi into xi. So this is the summation of sigma fi into xi, which gives us 5 plus 5 is 10, 15, and 5 is 20, 3 to 5, 6, 7, 8 to 10, 17, 17, and 2, 3, 3, 3, 6, 4, 10, 19, 25, 9, 34, and 6 is 40. Okay, now we can find the mean. We know the formula of mean. X is equal to, this is sigma fi into xi divided by sigma fi. So this is 470 divided by 100, which gives us 40.7 is the mean. Okay, now let's find out the median. So we have got our mean and median. We know that to find the median, we have to get the cumulative frequency and find out the median class. So let's find out the cumulative frequency. So cumulative frequency is 5. 5 plus 15 is 20. 20 plus 25 is 45. And 35 is 80. And 45 is 125. And 55, 125 and 55 is 180. 180. And we have to find the cumulative frequency. Sorry, I have added the class marks, we have to add the frequency. So this is 7, 7 plus 14 is 21, 21 plus 13 is 34 plus 12 is 646 plus 20 66 and 11 is 77 and 15 is 7 5 12 7 5 12 and 7 8 and 9 and 2 is 100. Okay, so now n by 2, which is 100, by 2 is 50, and this 50 we will get after 46. So this is the median class. So our median class is 40 to 50. Now let's write down the formula of median, which is equal to n plus n by 2 minus cumulative frequency upon h. Okay, sorry, it's not h, it's f into h, where h is the class size, l is the lower limit of the median class, which is 40, n by 2 is 50, and cumulative frequency is the cumulative frequency of the class preceding the median class, which is 46. Frequency is the frequency of the median class, which is 20 into h. H is the class size, which is 10. So this gets cancelled, it's 2. And now this is 40 plus 50 minus 46 is 4 by 2, 2, and the median is 42, which is between 40 and 50 in the median class. So our median is 42. And this solves our question number 34. Let's move on to question number 35. Before question number 35, part A, it's given that side AB and BC. So we are on question number 35. So this is question number 35, part A. And it's given that side AB, BC, and median AD of triangle ABC. So let's say this is triangle ABC, and it has median AD. And there is another triangle, which is triangle PQR. So this is triangle PQR. Okay, now, which has median PM, and it's given that AB, side AB and PQR are in proportion, and side BC and QR are in proportion, and median AD is in proportion with median PM. Now we have to prove that triangle ABC is similar to triangle PQR. Now let's make use of what is given to us. So this is side AB proportion with PQ, and BC is in proportion with QR, and AD is in proportion with PM. So let's write down what is given to us. So we have these two sides in proportion. If we are able to prove that this angle is also equal, then the triangle ABC will be equal by the SAS similarity rule. So let's try to get this angles equal. So this is given that AB by PQ. Now, if BC and QR are in proportion, that means half of BC is also in proportion with half of QR, and AB upon P1 will remain as it is. So AB upon PQ. Now half of BC is BD as well as DC, but we will go with BD. So this is BD, and similarly half of QR is QM, and this is equal to AD by P. Okay, now these sides are now in triangle ABD and PQM. So triangle ABD is similar to triangle PQM by SSS. Similarity. Okay, if these triangles are similar, that means angle B is equal to angle Q. So B is equal to angle Q. And reason being, these are the corresponding angles of similar triangles are equal. Okay, now let's move to the bigger triangles. So in triangle ABC and triangle PQR, so it's already given AB upon PQ. So AB upon PQ is equal to BC upon QR, and angle B is equal to angle Q. So therefore by SAS, similarity rule, triangle ABC is similar to triangle PQR. And this solves our question number 35th, part A. Let's move on to part B. And for that, let's try to draw the rough sketch of that. Okay. For part B, question number 35, part B. Okay, it's given that through the midpoint of the side of a parallelogram ABC. So let's say this is a parallelogram ABCD. And let's label it as ABCD. Now it's given that through the midpoint M of side CD, so side CD has midpoint M, a line is drawn intersecting AC in L. So AC is the diagonal. So line is drawn to intersect AC in L, and AD produced in E. So AD is produced, and this line intersects AD produced in E. Okay. Now we have to prove that. So it's given that ABCD is a parallelogram. So ABCD is a parallelogram, and we have to prove that EL is equal to 2 times PL. Okay, so to prove that, so EL, this is EL and BL. Okay, so these are in the triangles. EL is in the triangle AEL and BL is in the triangle ALB. So first of all, let's consider these triangles, and these triangles are BMC and EMD. So the triangles are BMC and EMD. So let's consider these triangles BMC, so EMD and BMC. So in triangle EMD and triangle BMC. Now for these two triangles, angle EMD is equal to angle EMD is equal to angle CMB, and these are vertically opposite angles. Similarly, AE is parallel and BC is parallel, so this is a transversal. It's also given M is the midpoint, so DM is equal to MC. DM is equal to MC because M is midpoint of CD. It's given that M is midpoint of CD. Okay, now this side we have taken this angle, and now this angle EDM. Angle EDM is also, this angle is also equal to angle BCM because these are corresponding angles. So we can say that by ASA, congruence rule, triangle EMD is congruent to triangle BMC. Okay, once triangle EMD is congruent to triangle BMC, that means that uh, Okay, so these triangles are congruent, so that means BC, this side BC, this is C, should be equal to ED. So BC should be equal to ED, so BC is equal to AD, but BC is equal to AD, but this BC is equal to AD. So BC is equal to AD, so that means I can write, so BC is equal to AD. This is because of the corresponding parts of the congruent triangles, and BC is equal to AD because opposite angles, opposite sides of a parallelogram are equal. So these are the opposite sides of a parallelogram. So BC is equal to AD, and that means AD is equal to, that means AD is equal to, so this implies that AD is equal to ED. So AD, and this is AD and this is ED, and these two are equal, and AE is now AD. We can write AD in terms, AE in terms of AD plus AD, and AD and ED are equal. So okay, so AD and ED are equal. So in terms of this AD, I can write BC. So this is AE. So AE is equal to, so AD is equal to BC, and we can write in terms, in place of AD, I can write BC, and AD. So AD is equal to AD and AD is equal to BC. So this is BC. So A is equal to 2 times BC because AD is equal to BC, and AD is also equal to, ED is also equal to AD. So instead of AD and ED, I can write 2 times BC. So A is equal to 2 times BC. Okay, now we have to prove that EL. So this EL is in triangle. EL is in triangle AEL. So we are going to consider these triangles AEL and the triangle AEL, and triangle BL is in triangle BLC. So triangle BLC. So in these two triangles, these two angles, angle L is equal to angle L. So these are vertically opposite angles. Angle L is equal to angle L. These are vertically opposite angles. So in triangle AEL also, uh, any of these angles, so this angle is equal to this. So that is, the name of this angle is EAL is equal to angle BCL, and these are alternate interior angles. So these triangles are similar, we can say, by AA, similarity rule, triangle AEL. Let's write the symbolic form correctly. So AEL, L is equal to L, and A was equal to C. So A is C and CBL. And once the triangles are similar, these corresponding sides are equal. So I can write AE by BC is equal to EL by BL. Now AE is 2 times BC. So AE, I can, for AE, I can write 2 BC by BC. This is equal to EL by BL. This gets cancelled. And if we cross multiply, so from where do we get this? We get this from 1, and this is 1. So we have replaced A with 2 BC. So this is 2 upon 1 is equal to EL by BL. And if we cross multiply this, EL will be 2 times BL. So this is what we have to prove. EL is equal to 2 times BL. For that, we first of all prove these two triangles congruent. And from there, we get A is equal to 2 times BC. And then we prove these two triangles similar. And once the triangles are similar, their corresponding sides are in proportion. Replace the value of A with 2 BC, and this gives us our desired result. So let's move on to section E, which has the case study questions. Okay, for question number 36, this is the first case study. And for question number 36, it's given that in an annual day function of a school, the organizers wanted to give a cash prize along a memento to the best students. Now, this is the shape of the memento, which is made of a base A, B, C, D. So this is the base A, B, C, D on which this is the memento in the circular form, and the rate of silver plating is rupees 20 per centimeter square. So each memento is made from the base, which is shown is front. This is the front side, and rate of silver plating is rupees 20 per centimeter square. We have to answer the following questions. Okay, now first one, what is the area of the quadrant ODCO? So quadrant ODCO is this one, and this has angle 90 degrees. So this is in the form of a sector. So area of quadrant, this is ODCO, which is equal to theta by 360 into pi r square. Now theta is 90 by 360 into 22 by 7 into r square, which is 7 into 7. This gets cancelled. This is 4, 11, and 2. So this is 77 by 2 centimeter square, which is the area of the quadrant OBCO. This is 77 by 2 centimeter square. Now find the area of the triangle AOB. Now triangle AOB is a right angle triangle, and for the right angle triangle we can use the formula half into base into height, and base is this side and height is this side, because the one opposite to the 90 degrees is the hypotenuse. So base is 7 plus 3 is 10, and height is also 10. So this is 50 centimeter square. Okay, moving on to question number third part A. What is the total cost of silver plating? The shaded ABCD, shaded ABCD is this region. So for that, we have to find the area of shaded region, which is equal to area of triangle AOB minus area of quadrant. Quadrant was ODCO. So ODCO. Now area of triangle AOB is 50 and ODCO is 20. So this is 100 minus 77 by 2, which will be equal to 10 minus 7 is 3. 23 by 2 centimeter square. This is the area of the shaded region. And we have to find the total cost. So total cost, so it's given that cost per centimeter square is rupees 20. So this is 23 into 20 rupees, which is equal to rupees 230. Okay, now for part B, we have to find the arc, length of the arc CD, and length of arc CD is by the formula theta by 360 into 2 pi r. This is part B of question number third, and it's 90 by 360 into 2 into 22 by 7. Radius is 7. So this is 4, 2, and 11. So which is equal to 11 centimeters. So the arc length is 11 centimeter, and this solves our question number 36. Let's move on to question number 37. यहाँ बच्चे को जबरदस्ती खिलाना पड़ता है Okay, for question number 37, it's given that in a coffee shop, coffee served in two types of cup. One is cylindrical in shape with diameter 7 centimeter and height 14 centimeter. So this has this cup has diameter, this has diameter 7 centimeter, the cylindrical one, and the other is hemispherical, and this has diameter 21 centimeter. Now the height of this cup is 14 centimeter. Now It's given that in a coffee shop, coffee is served in two types of cups, cylindrical and hemispherical. Based on the above information, we have to find the area of the base of the cylindrical cups. Area of the base of cylindrical cup, which is in circular form. So area of base of this cylindrical cup, we will use the formula of a circle, which is pi r squared. So pi is 22 by 7. The radius, diameter is 7, so radius is 7 by 2 into 7 by 2, which gives us the area as 77 by 2 centimeter square. First one is done. Second as part A, and we'll find the capacity, that is the volume. So, but this is the capacity of hemispherical cup. So this one has radius. Its radius is 7 by 2. This one has the radius 21 by 2. Now the capacity of the hemispherical cup is given by its volume formula. So this is 2 by 3 pi r two. So this is 2 by 3. Let's take the value of pi as 27, 22 by 7, because it's not mentioned. To take it as 3.14, and the radius is 21 by 2 into 21 by 2. So this is 7, 3 are 21, 2 and 2 gets cancelled, and now we have to multiply. It's 22 into 3 into 21 into 21 by this is 3 and 3 gets cancelled. So now it is 22 into 21 into 21. Now 22 into 21 into 21 is 2441, and 441 has to be multiplied with 2, so this is 288 and 882, so 10, 16, 17, and so this gives us the volume capacity as, okay, this is 2 by 3 into 2 by 7, 21 by 2 and 21 by 2 and 21 by 2. So let me just check it once again. 7 to 3 and 3, 3 gets cancelled. So it has to be divided by 4. Okay, so this is 22 into 21 into 21 divided by 4. Okay, so we can also cancel this. So now we can write it as 11 into 21 into 21 by 2, which gives us, let's multiply this. So 21 into 21, it's 24, which is 441 into 11 is, this is 441 into 11. So sorry, this is 441, which gives us 584,851 by 2. So this is now 4851 by 2 centimeter cube. This is the capacity of the hemispherical cup. Okay, now moving on to the next part, we have to find the capacity of the cylindrical cup as well. So capacity means volume. So capacity of cylindrical cup, which is equal to pi r square h, which is 22 by 7 into r square. R is radius is 7 by 2. So this is 7 by 2 into 7 by 2 into height. Height is 14. 7 and 7 gets cancelled. This is 11 and 2, 7. So this is 11 into 7 into 7, which is 11 into 49. And 11 into 49 is 539. So this is 539 centimeter cube. Okay, we have to find next curved surface area of the cylindrical cup. So curved surface area of cylindrical cup. Now it's given by 2 pi r. So this is 2 into 22 by 7 into radius is 7 by 2. Height is 14. So this gets cancels. It's 44 into 7. 7 4 that is 28. 7 4 that 28 and 2 is 308 centimeters square. Okay, and that's all for this question. Let's move on to the final one, question number 38. Question number 38, that is page 33. And for this question, it's given that, let's say, computer-based learning. It refers to any teaching methodology that makes use of computers for information transmission. And at an elementary school level, computer applications can be used to display multimedia lesson plans, like on the multimedia board. And the survey was done on 1,000 elementary and secondary schools of Assam, and they were classified with the number of computers they had. So these is the classification of the schools on the basis of number of computers. So this is the number of computers and the number of schools. Now, based on this information, we have to find the probability that the school chosen at random has more than 100 computers. So number of schools that has more than 100 computers. Now, more than 100 computers, so it's more than 100 computers are 80. And the total number of schools that were surveyed were 1,000. So our favorable outcomes are 80. And it was done on survey of 1,000. So this is 0.08 is the probability of the schools that has more than 100 computers. And the next question is, find the probability of school chosen at random has 50 or fewer computers. So number of schools that has 50 or fewer computers. So number of schools that has 50 or fewer computers. So that means the less than 50, and these are 250 plus 200 plus 290. So this is 250 plus 200 plus 290. So this is 450 and 450 plus 290. This is 4 and 7. So this is 740, and we have to find the probability of 50 or fewer computers. So 50 or fewer computers probability is equal to 740 by 1,000, which is equal to 0.74. Okay, now second part, find the probability that school chosen has random as no more than 20 computers. And no more than 20 computers means less 20 or less than 20 computers. So schools, number of schools with no more than 20 computers. So number of schools with no more than 20 computers. And no more than 20 computers means these are the computers. No more than 20 computers means 250 plus 200, which is equal to 450. And we have to find the probability of no more than 20 computers, which is 450, and total schools that was surveyed were 1,000. So this is 0.45. Okay, now last one, which has probability that a school chosen at random has 10 or more than 10 or less than 10 computers. So the third one, now let's first write down the number of schools that the school chosen has 10 or less than 10 computers. Okay, 10 or less than 10 computers are 250. So it's basically about reading this graph and then answering the questions. So probability of 10 or less than 10, 10 or less than 10 computers, school that has 10 or less than 10 computers, probability will be 250 by 1000, which is equal to 0.25. And this finishes our this set, which was okay, which was 34, 32, 1. And let's move on to solving the next set of series.